Isn't it just captivating when a rainbow pops up in the sky after a storm? That, vibrant curve of color always feels a bit like magic.
Oh, absolutely. A really breathtaking sight.
And if you've ever wondered, how does that actually happen? Well, you're in the right place today.
It really does make you curious, doesn't it? So today we're doing a deep dive into the science behind rainbows. We're drawing a lot from Dr. Nyagyeth Chol's book, The Science Behind Rainbows, A Kid's Guide to Light and Color.
Right. And don't let that kid's guide part fool you.
No, not at all. It's genuinely a fantastic resource for, well, anyone who's looked up at a rainbow and just thought, how?
Exactly. And I love that Dr. Chol dedicated it to curious minds. Okay, so let's map out what we're going to cover today.
Okay, so first up, we need to tackle the very essence of rainbows, light itself, what it is, what it's made of.
Makes sense.
Then we'll get into the nitty-gritty of how rainbows actually form step by step. And of course, we have to talk about the colors, right? ROY go.
Ah, yes. Good old ROY-GBDO.
Why those specific colors and why always in that order.
Yeah, that familiar sequence.
Yeah.
But I suspect there's probably more to it than just the standard rainbow we usually see.
Oh, no, definitely. We'll look into all sorts of different types. Double rainbows, which are pretty common.
Always a treat to see those.
But also rarer ones like moonbows, fog bows, even those sort of upside down ones. Plus, we've got some really fun hands-on experiments you can try at home.
Oh, practical science. Love it.
Yeah, to really see it in action.
Huh?
And we'll sprinkle in some fun facts and make sure we cover the key science concepts behind it all.
Sounds like a fantastic journey. So basically, our mission today, listener, is to go beyond just seeing the beauty. We want you to really get the science. So you can maybe explain it or even, make your own little bit of rainbow magic. Ready to jump in?
Let's do it. Okay, starting right at the beginning. Light. I mean, everything we see, all the colors, it's all thanks to light. But what is light, fundamentally?
Well, Dr. Chol explains it as these incredibly tiny, really, really fast particles.
Photons, right?
Photons, exactly. Little packets of energy. But here's the thing that always gets me. Sunlight looks white, maybe yellowish,
Yeah, to our eyes.
but it actually has all the colors of the rainbow hidden inside it.
That's the crucial part. It's not just one thing, it's a mix. Like think of white paint being a mix of pigments, but with light, it's additive. All the colors together make white.
Okay.
And this white light can be split apart. It happens when light passes through something that makes it bend and separate.
Like raindrops.
Yeah,
Or a glass prism.
precisely. That's how we see the spectrum. And it's not just particles, is it? Dr. Chol also talks about light traveling in waves.
Right, like ripples on water.
Exactly. And these waves have different lengths. That wavelength is what determines the color we actually see.
Ah, okay, so wavelength equals color.
Pretty much. Red light has the longest waves, which is why it's always on the sort of top or outer edge of the main rainbow. It bends the least.
Right.
And violet, on the other hand, has the shortest waves, so it bends the most and ends up on the inner edge.
So the order isn't random at all. It's pure physics. Longer waves bend less, shorter waves bend more.
You got it. And that famous acronym ROYGBV.
Red, orange, yellow, green, blue, indigo, violet. Still got it.
Huh. It sticks with you, doesn't it? It's just a great way to remember that order, which directly corresponds to those decreasing wavelengths.
Okay.
And it's important, like Dr. Chol points out, that for rainbows, we're talking about the visible part of the light spectrum. There's way more light out there, radio waves, X-rays, but the rainbow is the bit our eyes can actually detect as color.
Right, just our little slice of the whole electromagnetic spectrum.
Yeah.
Okay, so we've got this white light full of colors traveling in waves. How does it actually transform into that arc in the sky?
Okay, so the recipe needs two main ingredients: sunlight and raindrops. Lots of tiny raindrops hanging in the air, usually after a shower.
Sun and rain. Got it.
So first, that sunlight, which we know contains all the colors,
Yep, the hidden raindrop.
enters a raindrop. Now, these little water droplets, Dr. Chol says they act like tiny prisms.
Okay, like miniature glass triangles.
Exactly. And as the light goes from the air into the water of the raindrop, it slows down a bit. This change in speed makes it bend. That bending is called refraction.
Refraction, okay. So the light enters and bends.
Right. And here's the key. Different colors bend by slightly different amounts. Remember the wavelength?
Yeah. Red bends least, violet bends most.
Precisely. So right as the light enters, the colors start to separate out because they're bending at slightly different angles. That's step one of the separation.
Okay, colors are starting to split. What's next inside the drop?
So now this slightly separated light travels through the raindrop until it hits the back inner surface of the drop.
Uh-huh.
And there it reflects. It bounces off, kind of like hitting a tiny curved mirror.
So it bends going in, then bounces off the back.
Exactly. Reflection. And this reflection sends the light back towards the front of the raindrop.
Okay, is it done splitting colors now?
Not quite. As the light heads back out of the raindrop, it goes from water back into the air.
So it speeds up again.
And bends again. Another round of refraction as it exits.
Ah, refraction number 2.
Yes. And this second bending spreads the colors out even further. So by the time the light leaves the raindrop, it's no longer a white light. It's a beautiful spectrum of colors, all traveling in slightly different directions.
Wow. So bend, bounce, bend again. That's the journey through the raindrop.
That's the essence of it.
But why the arc? Why do we see that curved shape? Not just random flashes of color.
Great question. It comes down to the angles. Each color exits the millions of raindrops at a very specific angle relative to the path of the sunlight coming in your eye.
Okay.
For the main, primary rainbow, all the red light that reaches your eye comes from raindrops that are at an angle of about 42 degrees from that incoming sunlight path.
42 degrees for red.
Roughly, yes. And all the violet light comes from raindrops at a slightly smaller angle, around 40 degrees. Orange, yellow, green, blue, indigo, they all fall neatly in between those angles.
So my eye is collecting all the red light from drops at the 42-degree angle, all the orange from drops just below that, and so on.
Exactly, forming that distinct arc. And that's why everyone sees their own rainbow. The person standing next to you, they're seeing light from a completely different set of raindrops.
Wow, a personal rainbow. That's kind of cool.
Isn't it? And it also explains why we usually just see the arc. The full circle exists.
But the ground gets in the way.
Exactly. The horizon cuts off the bottom half. But if you are high up, like in a plane, looking down on rain clouds with the sun behind you...
You might see the whole circle.
Yeah.
Amazing. I'd love to see that.
Yep.
So, okay, if I want to spot a rainbow, basic rules.
Keep it simple. Sun behind you, rain in front of you.
Got it. Back to the sun, face the rain.
And you're looking for sunlight hitting those raindrops at that magic angle, that 40 to 42 degree zone. So next time the sun peeks out while it's still raining, turn around and look.
Will do.
Yeah.
Okay, let's zoom in on those colors again. ROYGBV.